Good morning, friends. In this video, we are going to discuss about various power tariff types and different curves related with load distribution and economic of power plant, whether it is a thermal power plant. Mostly, we are concentrating on thermal power plant since 70% of the power we are deriving from thermal power plant, that is coal-based power plant. So, we will discuss in detail about various types of power tariff and load distribution methodology and how we are calculating the cost. So the load duration curves, we will start with this load duration curve, and the load curve also we are having. The difference between the load curve and the load duration curve is the load duration curve will be in the descending order of power utilization, whereas the load curve will give hourly basis from minute, minute 12 to 2 and 2 to 4. Sometimes it may go up, sometimes it may go down. Ups and downs will be there in the load curve, whereas the load duration curve, it will be in decreasing order. That is, will be rearranged. But both the curves, load duration curve as well as the load curve, will give you the total energy consumed, or total energy generated, or total energy derived from any power plant. So when before planning for the power plant, we have to consider two basic parameters like total power output to be installed, how much power is going to be generated, and the size of the generating units. How we can calculate the installed capacity. The demand, we have to estimate how many houses are there or how many industries demand we have to calculate. We have to do the complete survey. What will be the demand during the peak hour? Based on that, we have to go for capacity of the power plant. And we will consider the growth of the demand in future, how it will get expanded. And we have to consider the reserve. For any power plant, we have to have some surplus power generation. That also has to be considered. So by considering these three, we will decide the capacity of the power plant to be installed. That is the demand, growth of the demand, that is anticipation growth, and surplus reserve capacity of the plant required. As I mentioned, the load curve, total capacity of units connected to the electric grid, minimum startup and shutdown periods of the units, plant efficiency, price, and the space demand per kilowatt. These are the things we are going to discuss. Location, where we can locate the power plants. The hydroelectric power plant is usually predetermined based on the availability of water, that is near the dam, near the catchment area, like Metur, Satunur, and other hill areas, some hill areas in Nilagiri district, where we have continuous flow of water from with high potential energy. There we can go for hydroelectric power plant. Whereas a thermal power plant and nuclear power plant, we have to install where we have huge amount of water circulation, mostly near sea. We have abundant, unlimited quantity of water, so that can be used for cooling. So we have to resalination plants, and we have to purify the water. We have to treat the water, feed water treatment. Then it will be used in any power plant, whether it is a thermal or nuclear. So that is very foremost important point to be considered before selection of power plant. Near sea, mostly near sea, we will be choosing the site. And transport is another method, whether it is nearer to rail. Since we have to import coal from different places, we have to import from foreign countries, or we have to bring from inside the country also. For that, we need transportation facility and the distance from the residential area, whether load distribution, whether it is far away from the residential area or nearer. At that point also we have to consider. And the land cost, soil test we have to take before starting any industry, whether it is a power plant or any industry. We have to go for the soil test. That is very essential. And wind direction also sometimes matters, since cooling tower we have to install, and disposal of waste, that is in the thermal power plant disposal of ash, in the nuclear disposal of nuclear waste. If the power plant is located far from town, then we have to go for accommodation for staff. And finally, road and rail and road connection, that is known. So these are the essential factors before considering the installation of power plant, that is the location of power plant. Okay, when we come to the power plant economics, that is very essential, very important. So what are the major costs involved? That is fixed cost, that is the land cost, building cost, maintenance cost, depreciation, interest, taxes, everything will be included, building, car, land, etc. Operation and maintenance, that is for repair of equipments, maintenance of the equipments, buying spare parts, lubricating oil, chemicals, and mainly salaries and wages for the employees. Fuel cost is dependent on the amount of electricity generated, kilowatt hour of electricity sent out per year. These are the four parameters in power plant economics. The total annual cost, capital C, in a power plant can be calculated I plus D plus T by 100, where I is the interest, D is the depreciation, T is the taxes and insurance, C is the construction cost, wages and salaries are divided by W, R is repair, that is maintenance, M is miscellaneous, and C is the fuel cost. Based on this, we will be calculating the total annual cost. Now we look at this load curve. See, if you look at this, highlighter, I will go to the highlighter. So this is called the residential load. This is a street light. This is metropolitan area. This is for 24 hours they have given. Midnight to 12 to next day midnight. That is the 24 hours. See, if you look at this graph, residential area, the power consumed will be maximum during the period 6 to 6. Whereas the street light will be operated only in the night, that is 6 to 6. In the metropolitan, the curve 6 to evening 6, after evening 6, we will be getting the peak demand. Whereas in the morning, it is constant 12 to 6 and the 6 to 12, that is for street lighting. And the weekdays, if you look at the graph, weekdays, it goes like this for Saturday and Sunday. So the graph shows hourly variation in energy demand for different types of electrical load and curves of total load in metropolitan area. Load factor, that is an important factor, it should be always less than 1. The load factor is calculated by means of the ratio between average load and peak load during the given period of time. Average load by peak load. Per year, 8,760 hours. So for that we can calculate load factor. If a plant has a peak load of 1000 megawatt, but average annual load is 350 megawatt, its annual load factor would be 0.35. So load factor should be less than 1. So most of its capacity remains unutilized the major part of the year. Also, so the cost would be high. So here what we have to understand is, we have to see to that load factor always nearer to 1, 0.8, 0.7 likewise. If it is 0.35, that means most of the time the power is not utilized. We are generating the power, but the generated power is not consumed by the consumers. So it is a wastage of manpower, wastage of money, wastage of fuel, wastage of raw material, and wastage of maintenance. All those things will go in vain. So Load factor is a very important factor to decide whether the plant is running in normal condition, that is with profit. Now look at this load curve, typical load curve based on the hours. Here we will have the ups and downs, whereas the load distribution curve we will have only in the descending order. The capacity factor can be calculated using the formula average load by rated capacity. The load duration curve. This is called the load duration curve. The peak load, whether it comes in the middle or not, it has been placed here, then it will be in descending order this way. So this is called load duration curve. Location we have seen. Now we will see one simple problem to draw the load curve. They have given time in hours, that is midnight to 6 morning AM, morning 6 to 10, 10 to 12. Likewise, they have given, and the load utilized 30 megawatts, 70, 90, 60, 100. The peak load here is 100. This is called the peak load. And in the second case, what they are asking is how will you calculate the load factor if the standby plant, that is a generator, is being used of 30 megawatt capacity. What is the load factor they are asking? So the load curve, this we can easily calculate the energy generated. The energy generated can be easily, energy generated is 30 by 6, 70 by 4 hours, 90 by 2 hours, 60 by 4. Likewise, we can calculate the energy generated, and the total energy generated will be 1560. This is a load curve. First is 6 hours, 30 megawatt. Next 4 hours, 70 megawatts. Then 2 hours, 90 megawatts. Again here we have 60 and here we have 100. Likewise, we are drawing the load curve and we are doing this calculation. And this is another example, load factor equal to average load by peak load. So in this way, we have to determine our economy of a power plant. So thank you for watching this video. I hope this video would have given you sufficient material idea about economics of power plant. Thank you.